All right, guys, today we're going to look at functions, equations like function tables, and some graphs. It is very similar to things that we have seen in the past. So some of this is going to be old, some of it's going to be new. And then we are going to also be able to write an equation based on a function table. A function table is like a ratio table. So a lot of this is connecting to little topics as well. So remember, a function is the relationship between your x and your y. So your x-axis and your y-axis. We have what are called independent variables, which is your input. What are you plugging in? So that's your x. And your dependent variable is your output, which depends on what happens with your x is your y-axis. And then remember, an ordered pair is your x. You go forwards or backwards, and then up or down. A function rule or equation in this case would be basically telling you what to do in order to get your answer. So basically, we're solving equations in a sense. Okay, we're plugging them in. So for instance, for the first one here, again, this one should be very simple. If I tell you the input x, the independent variable, is 4, what would be my output? So all you do is 4 minus 4, and that is 0. So my ordered pair there would be 4, 0. And then I plug in 7. 7 minus 4 is 3, and therefore my next ordered pair would be 7, 3. And then 10 minus 4 is 6. So then my last ordered pair in this situation would be 10, 6. So if I was asking you to graph that, then you would plot those points on an ordered grid. Okay, same thing applies for this one. But remember, we still need to make sure we're following the order of operations. So again, remember that this is 3 times x, so x is 0 plus 5. And this would be 3 times 2 plus 5, and then this would be 3 times 5 plus 5. You have to follow the order of operations, so I should be multiplying before I add. So then 3 times 0 is 0 plus 5 is 5. 3 times 2 is 6 plus 5 is 11. 3 times 5 is 15 plus 5 is 20. So my ordered pairs would be 0, 5, 2, 11, and 5, 20. Very simple, just plugging them in, getting the output for your dependent variable. Okay, however, we get to this one and then I trick kids up here. So this one is 100 minus 5x. So I would do 100 minus 5 times 7, 100 minus 5 times 11, 100 minus 5 times 25. But according to the order of operations, you should be multiplying before you add or subtract. So the first one is 100 minus 35, and then that gives you 65. Okay, next one is 100 minus 55, which is 45. And then $1 minus 5 quarters. 5 quarters. 5 quarters is $1.25, right? So 100 minus $1.25, you're actually in the negative 25, but that one's just like an extra little thing there. So be careful that you are following the order of operations. So therefore, my ordered pairs would be just like the ones I did before there. Okay, so the last one obviously is higher than, you're borrowing more than you actually had, so that's why it's negative. But we know how to do that. So now, what if I give you the answer and I'm trying to have you find the input? So I give you the dependent variable. What is the independent variable? It's just like how we solved equations. We do the inverse. You do the order of operations backwards. So the first one is honestly, to me, pretty simple. So if I knew that I was going to have x minus 3 is 2, so it's kind of like saying x minus 3 is 2. How would I get my answer? I'd add 3 to each side, right? So in this case, the inverse of subtract 3 is add 3. So if I'm going this way, I'm just adding 3 to that, which is 5. I'm adding 3 to this, which is 7. And I'm adding 3 to this, which is 10. So it's basically solving an equation, okay? So you're using the inverse. Where it gets a little bit tricky is when you have multi-step, okay? So I'm trying to figure out what x is. If you're confused, you plug back that answer in. So if I have a problem like this, I have 2x, and then subtract 7 is my equation, and I know the answer is 11. So we talked about that a little bit. If I have 2x plus 7 is 11, I'm technically going to subtract 7 first, like we talked about. So if I subtract 7 first, what do I get? Well, if I subtract 7 first, I end up getting 2 x's equals, let's see, that would be 5, 6, 7, 4, 4. Okay, apparently my brain is not working. And then I just have to then do the inverse. What's the inverse of multiplication? Then I would cut it in half or divide by 2, which we talked about that, which the answer is 2. So the answer is 2. So what we're doing is we're taking the answer and we're doing the order of operations backwards. So you can either write it like we did before, like solving two-step equations, or you can kind of follow this method here. So if I do the next one without doing it, solving like a two-step equation, I would take 15 and then I'd subtract 7. So 15, I'm going to go and erase this. I have a 15 minus 7 is 8. And then I would cut it in half. Cut it in half is 4. Okay? How do you know you're doing it right? You could, again, make sure you plug it back in. 2 times 2 is 4, plus 7 is 11. 4 times 2 is 8, plus 7 is 15. So let's do the last one here. 27, let's subtract 7. So 27 minus 7 is 20. And then I'm going to then cut it in half, which is 10. And then again, check your answer. 2 10s make 20, add 7 is 27. So it is like solving a two-step equation. Just again, this is another way to show you how to get the answer. Now, this one is same idea. However, I threw in a little bit something different. So I now have x being divided by 2 and then subtract 1. So if I made this an equation, x, whatever x is, cut it in half, take away 1, I have to get 11. So if I was to ask you to solve this equation, remember what like we did before, we need to get rid of addition or subtraction first, because it's like the order of operations backwards. So I would add 1 on each side first, right? So if I add 1, that would be my first step. And then I have x is cut in half equals 11 plus 1 is 12. Well, then how do I get rid of division? What's the inverse of division? The inverse of division is multiplication. So I times both sides or multiply both sides by 2. So therefore, my answer here, if I multiply then by 2, going in the opposite direction using all the inverse, I then get, what is x? X is 24. So let's see if that makes sense. If I take 24, cut it in half, I get 12. Subtract 1, I get 11. So I did it right. So then you could either follow this method and do it every single time for each of these, or we can just kind of follow the pattern here. So if I take 15, just like we did here, inverse of subtract 1 is add 1. So if I take 15, add 1, I get 15, add 1, I get 16. And then we are going to then multiply by 2, because that's the inverse of divide by 2. Double it up, I get 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32 Half of 32 is 16. 16 minus 1 is 15. So I did it right. Same thing here. If I add 1 first, I get 27 plus 1 is 28. And then we need to then not divide by 2 because we're doing the inverse, so multiply it by 2. If I double it up, 16, 4, 5, you get 56. And again, check it by plugging it back in, plugging it back in, plugging it back in. So you're just basically doing the inverse operations backwards. Okay? So just like how we solve two-step equations. Now, what if I already give you the equation? So it says I bought a bag of jelly beans. They cost $3 per pound, and I've also bought a bowl, like a candy dish, to put them in for $2. Let P be the number of pounds, and let C equal the cost. So instead of putting X and Y, technically pounds is your X, so P, and your C is your cost, which is your Y. So basically here, it's just replacing your X and your Y with different letters. No big deal. This is the equation that they're giving you. So all you have to do is plug in the information into the equation to get your answer. So if I plug in P is 2, so I have 3 times P plus 2, and I say P is 2, so 3 times 2 plus 2, 3 times 2 is 6, plus 2 is 8. So the answer here would cost me $8. I bought 3 pounds at about 2 pounds at $3 each plus a candy dish. I only bought 1 candy dish. Same thing here, do the same thing. If I plug in P is 3, 3 times 3 plus 2, that's 9 plus 2, which is 11. So I spent $11. So how would I go in the reverse? Well, if I know 3P plus 2 is 17, I need to do the inverse order of operations first. Just like we talked about, I'd subtract 2 first, right? So if I subtract 2 going backwards, I get 15, right? And then how do I get rid of division, right? Or multiplication, I'm sorry, since said the answer. Since this is multiplication, then I would divide by 3 going in this direction. So if I cut this into 3 parts, I then get 5. I'm doing again what we just did in the chart. This time I just don't have that middle section. So you would subtract 2 first, and then you would divide by 3 second. I'm doing the inverse. So therefore, the answer is 5. Let's see if that's true. 3 times 5 is 15, plus 2 is 17. So I did it right. So I was just kind of trying to show you the relationship between what we did before to this. Now I give you a different equation. Okay? Now, what about this one? The Quinn family drove at a rate of 55 miles per hour. If you look right here, this should make sense. 55 times the number of hours is the number of miles. Let's fill in the function table. So all again I have to do is plug in the information, do exactly the same thing as before. So if H is 2, all I do is plug it in. So 55 times 2 is 110. Then what if H is 3? 55 times 3, that's 15. Carry the 1, 165. But if I need to go then in the opposite direction, right? Because I'm multiplying by 55, multiplying by 55, going in this direction. How do I go in the opposite? I am doing the inverse, which is divide by 55. So 55 divided by 440. So you can kind of try to make an educated guess. If times 2 is 110, what would be 440? Let's see, times 4 would be not enough, right? Times 5, times 6, times 7. Let's see, 5 is going to be too low. Let's try, I don't know, 6. Okay, 6 again will be too low. So this would be 30, and this would be 30, 30. So the answer is 8. 55 times 8 is, that's a 40, and that's a 44. So the answer is 8. How do you know you did it right? 8 times 55 is 440. So again, inverse. So basically what I was doing here on this problem, I was first multiplying by 3, then I added 2. This one I multiplied by 3, then I added 2. This one I subtracted 2 and then divided by 3. Again, it's the inverse. Okay. So then we have problems where now I just give you a data table. I give you an input and output table, X and Y. Okay, so again, we are going to write the equation. So I'm trying to figure out how am I going from my X to my Y, the relationship between X and Y. That means I'm looking at the relationship going in this direction. What am I doing to X to get my Y? So you could do it two different ways. You could start with Y equals X plus minus multiply, divide the number, or I could do it X plus minus multiply, divide the number equals Y. Either way, it doesn't matter. So how do I go from my X to get to my answer, which is your Y? Has to work for all of them. So how could I go from 1 to 9, 2 to 10, 3 to 11, make sure it works for all of them? Does times 9 work? It doesn't. It works for the first one, but it doesn't work for the other ones. So if you said you're supposed to add 8, you are correct. Because 1 plus 8 is 9, 2 plus 8 is 10, and so on and so forth. It works. So your equation can be X add 8 is my Y, or you could put Y equals X plus 8. However, you do know, since it is addition, you could flip it, or you could flip the X and the 8 around. Be careful though for subtraction. So same thing here, how to go from here to here, here to here, here to here, here to here, here to here. Has to work for all of them. Is it add 6? No, it works for the first one, but it doesn't work for the second. So it's times 7, times 7, times 7. So I take my X, I'm multiplying by 7 to get my answer. Okay, we know the pretty way to write it is this way, or you could flip it around, which in algebra, you will see it written this way. In algebra, you will see it typically written this way. Okay, but again, all of the ways that I wrote it are correct. You could technically even write Y equals 7 times X, but again, we know how to show that differently with your coefficient. Not too bad. Okay, last but not least, what if now I give you a graph and I say, okay, what is the equation? How am I going from my X to my Y? So here's a suggestion. Take 2 points, 3 points, whatever, write it out. So my X to my Y. So if I look right here, let's just do these first 3 dots. Okay, this dot here is at 3. So my X is at 3. My Y is at 11. So X is 3, Y is 11. My next one is at 4 and 12. 4 and 12, so 4 and 12. And the last one, if you can kind of see now, is 5 and 13. 5 and 13. So what's your equation? How do I go from my X to my Y? X to my Y, X to my Y. If you said you're adding 8 for every single one, you're correct. So you could write X add 8 is my answer, or you could write Y equals X plus 8. I prefer the second way where I wrote it, but again, it doesn't matter. They're the same. Same thing here, do the same idea here. Again, finding your ordered pairs. Pick 3, you gotta at least pick 3 to be really sure that you have the right one. Again, this is at 3, 6, so 3, 6, so 3, 6, 4, 8. Let me guess, the next one is 6, 12, 6, 12, 4, 8, 6, 12. Hopefully you see the pattern here. It is doubling it up, doubling it up, doubling it up. So X multiplied by 2 is your Y, or the pretty way, Y equals 2X. Okay? So in the last questions, I had a different letter, but it still met my input, my output. my independent, my dependent, my X and my Y. So sometimes I could change this to, I don't know, B, and this is a C. So the only difference is this would be a B plus A equals C. That's all. It's just changing the letters, but it still means the same thing. Okay, and then sometimes maybe I will give you a chart and I say, okay, which one matches up with this? Which one is showing me X subtracting 2 is my Y? So if you look here, you go ahead and just write your order of pairs down. So this is 3, 4. This is 4, 5. And I'll look at one more. And this one is 5, 6. Is that subtracting 2 from each of these going this way from your X to your Y? No, it's not. So this one should be right. Let's see. This is 3, 1, 4, 2. Yeah, 3, 1, 4, 2. So this got to be 5, 3, and it is. And am I subtracting 2 from my X to my Y? X to my Y, X to my Y. I am. So B is the answer. So that's just another way to do it. If you're not sure, then you can also make a T-chart. Okay? Figuring out what is the relationship between your X and your Y. Not up and down, left to right. What is your relationship between your independent and dependent variable? That's a function. That's how you write the equation. Okay? That's pretty much it. All right. So, let's see. I think that was it. Yep. All right. So go ahead and start the assignment.